Welcome to Study Loop.
This is the answer to Chapter 21, problem number 68 from the Smith Organic Chemistry textbook. And this problem asks us to carry out the reaction that I've drawn at the top of the screen here, which is to synthesize this aldehyde that they call A, or hydroxyaldehyde A, from cyclopentanone and 4-bromobutanol. And so looking at these two molecules, what should be immediately apparent is that a Grignard would get this done nicely. However, with the aldehyde present, the Grignard, once we form the Grignard, it's going to react with itself and multiple equivalents of this second reagent here, the 4-bromobutanol, are going to end up reacting with themselves and one another rather than the cyclopentanone. And so what we have to do is protect that aldehyde so that we can get reaction only at the ketone from the cyclopentanone, and then deprotect that aldehyde to get our final product. So the entire point of this problem shows the utility, the usefulness of the acetal protectant group as a strategy in synthesis. So starting with the 4-bromobutanol, what we're going to do is treat it with ethylene glycol and tosic acid. In order to form the acetal. And so once we've formed the acetal, now we can go ahead and use magnesium and ether. I don't like that ether is always left out. Magnesium and ether, and form our Grignard. And it won't react with itself now, and so it will be available to react with our desired ketone, which is the cyclopentanone. So just a straightforward, typical Grignard reaction here. So I guess we would do a water workup afterwards, as we always do with a Grignard. And so that's going to get us to this point. So we've done our Grignard. So there's our hydroxy group. We've added the carbon chain that we want to add, but it is still acetal protected. And so all we have to do at this point is remove that acetal protectant group, which is easy enough with just some acidic water, H plus H2O. And that gets us our aldehyde back, and that's our final product. And so again, all we have to do to make this work is employ an acetal protecting group strategy to prevent the aldehyde and the starting material from reacting, and to get reaction only at the ketone. And that's really the point of this problem, just showing the utility of the acetal protecting group in synthesis. And again, that's the answer to Chapter 21, problem number 68.